Hello, my name is Jenny Gardner. I'm an academic coach here at SNHU. Welcome to this guide on composition of functions. Today, we will begin with what a composition function is. Then we will lead into the notation. And finally, we'll conclude with some examples. Let's start with that vocabulary and notation. So when it says composition of a function, you will have two functions. You can have more than that, but we're going to talk about two. If you have two functions, what's happening is you are inserting one function into another. And the order will matter. So if it tells you to insert f into g, that's important to know. If it tells you to insert g into f, that's important to know. If it tells you to insert function 1 into function 2 versus function 2 into function 1, that's important to know. Now, these functions might be labeled as f of x and g of x, but they can have other letters too, and that's okay. The letter that represents the function does not matter. What matters is that they are different functions that need to be put into one another. So each of these functions will have an assigned formula, value, polynomial, whatever it might have, that you are going to use to insert into the other. So we're going to see how that happens. But after you insert it, you also have to remember that you can combine like terms. That's really important. You shouldn't just leave it as is after you finish. And then other items that you could do are graphing and solving the equation. And the notation might look like this. You see that little circle? That is the notation for composition of a function. So if it says f of g, the composite function f and g of x, it's saying to insert g into the f function. So let's look at what that means. So here I have two functions. I've assigned some values to those functions. Function 1 is f of x, function 2 is g of x, and they have different values that have been assigned here. Now this first example says f of g. We're going to insert g into f. So f of x is negative x plus, hold on, we're going to erase that real quick. Negative x, and then I write the plus really far over, because that x is going to disappear. That x is being replaced. It's no longer x, it's actually going to be the entirety of g. G is going to become a substitute for our x. It's going in there instead. So instead of x, we're going to erase x, and we are going to put our new g into the problem. So that was 15x squared minus 4 has been inserted for x, for our variable. Our variable became the whole function g of x. G of x went into the function. I've said it enough ways, I think. But if you need to review what I just did, take it back a second and rewatch. But we also have another example coming up that you get to see it again. So now that we've inserted that in there, we need to solve and figure out what happens. The negative needs to apply and distribute to both terms. So it's going to be a negative 15x squared minus a negative 4 plus 3. We can't forget our plus 3. And when we subtract a negative 4, that becomes plus a positive 4. If you don't know the negative rules, definitely look those up, learn them. It's a good thing to know. And so this would be negative 15x squared, and we can combine like terms. The 4 and the 3 are both numbers that do not have a variable next to them, so they can be combined. So 4 and 3 is 7. Negative 15x squared plus 7 is our final answer for this composite function. So on this next one, we need to be clear about what order we're working with, because we still have the same functions here, and we want to make sure that we focus on the correct order. So this might be a good place to pause and try it out for yourself and see if you can do it. This time, f of x has replaced x. So we take the original function of g of x, the 15x squared, so there'll be something squared, minus 4, but that x is replaced by the other function. So instead of inserting g into f, we're going to instead do it in the reverse and insert f into g. So let's erase this part here. Okay, so up here, if we look, our x is going to be replaced by negative x plus 3, because that is the one that needs to be put into the other function. So negative x plus 3 will go inside where x should be. Where x squared was, we will have negative x plus 3 squared. Now it's important to note that that means that we have some work to do. We have to figure out, well, what is negative x plus 3 squared? Because it's not as simple as just squaring negative x and squaring 3. We're squaring the whole thing, which means we need to take negative x plus 3 times negative x plus 3. So anything that was applied to x the first time now needs to be applied to the whole formula. So negative x plus 3 times negative x plus 3, we can apply FOIL. First, outside, inside, last. So we'll have first negative x times negative x, which will equal x squared. Then we'll have outside, negative x times 3, that's negative 3x. Inside, 3 times negative x, which is another negative 3x. And last will be 3 times 3, and that's going to be 9. So we had everything in this term multiplied by every term in this as well. And so we're able to apply FOIL and find our polynomial. And this will become x squared minus 6x plus 9. So negative x plus 3 squared becomes x squared minus 6x plus 9. But we still have to apply the 15 multiplied to that, and we have to remember our minus 4 at the end. So our next step is going to be to multiply out that 15 and distribute it to every term within the polynomial. So that means that 15 gets multiplied by x squared, 15x squared. It means we take our negative 6x and we multiply it by 15 as well. Take a second and check out what that would be. 15 times a negative 6, and double check your negatives there. And you should get a negative 90x. And lastly, we'll need to take 9 times 15, and notice that that one's positive, 15 times 9. And that's going to be 135. And we cannot forget our minus 4. I promise you, you're almost there. We're almost finished, because all we have to do now is combine our like terms. And the only like terms we have are 134 minus 4. So the final answer on this bottom one is 15x squared minus 90x plus 131. And that should be our final answer. So we went over an easier example for the first one, and then a little bit of a more difficult one where we had to use FOIL for the second one. And if we knew what x was from here, if we already knew the answer to x and we knew that we wanted to find out what the composite function equaled at a certain point, we could put that value in for x and solve for an exact value. And that would totally work as well. We could graph this and look at what it looked like individually for f of x and g of x, and what it looked like when it was together as a polynomial. That's the composite function on the bottom, or on the top, that smaller polynomial that we had there when we solved that one. Congratulations, and thank you for watching Academic Support's guide on composite functions. Please read the video description for further resources. Thank you so much. Have a wonderful, wonderful day.